Hey everybody! Today I want to quickly go over some basic laws of intersections and unions. This is going to cover the commutative law, the distributive law, and the associative law of sets. So first, the commutative law. A union B is the same thing as B union A. They're commutative. Same thing as intersection. A intersection B is the same as B intersection A. To visually display this, if we have A union B, that means we care about everything in A, and then we union it with everything in B. Well, if I flip it around and say, okay, B union A, I care about everything in B, and then everything in A, notice I get the same picture. Now moving to intersections, I say, okay, I'm going to look at everything that A has, and then I'm going to shade whatever B has in common with it. Well, if I flip it around, I say, okay, I care about everything that B has, and then I care about only what A has in common with it. Notice I have the same picture. Moving on to the associative law, this means you can move your groupings around. You can choose which sign you want to do first. So A union B unioned with C is the same thing as A unioned with B union C. Similarly with intersection, the group of A intersection B, then intersected with C, is the same thing as A intersected with the group B intersects C. So to visualize this, again on Venn diagrams, I'm going to display it. First, we'll do A union B, which is everything in A, and then everything in B. And then we take that new set that we've created and union it with C. It's just everything in C. Now we're going to care about B union C first, which means everything in B, then everything in C. And then we're going to union A with that new set. So everything in that set and everything in A. Notice we shaded both of the same areas. Next, on to the intersections. First, we're going to do A intersect B, which is what the two have in common. And then we're going to intersect it with C. So really, we care about this part, what our intersected set has in common with C. Next, we're going to intersect B and C first, which gives us this part. And then we're going to intersect A with that set, which is going to just be this middle area. Notice the pink area is the same in both pictures. Now we have the distributive law. The distributive law is just what it sounds like. In a sense, you can distribute the operation of the sets. So for example, here we have A intersected with the set B union C, and that's the same thing as A intersected with B and then unioned with A intersect C. Similar with unions, we have A unioned with the set B intersect C, and that's the same thing as A union B intersected with the set A union C. So visually, first we look at everything in A, and then we're going to look at everything in B union C, which is just everything that those have in common. And then we want to find the intersection of these two sets, which the intersection of B unioned with C, which is all of that, intersected with A, is simply this odd shape there. So now we're going to do the other side. If we first care about A intersect B, we get this area. And if we care about A intersect C, we get this area. And the union of the two means we get that odd shape again. Now for the next line, if we first care about B intersect C, it's going to be right here. And then we want to union it with A, we get this shape. If we do A union B first, which is this shape, everything in A and everything in B. And then we care about A union C, which is going to be, I'll do that in blue, everything in A, everything in C. And then we care about the intersection of the blue and the black sets. I'll do this in pink. We get everything here and here, which notice is the same shape as we got in this third block. And those are the basic laws.